Okay, welcome again, everybody. We are nearing the end of the second day of the conference. However, first we have a team of 4 Microsoft product group speakers who update you on what's all happening to Azure API Management. So let's quickly move over to Vladimir and his team. So over to you.
Yeah, thanks, Lex. Hi, folks. Thanks so much for joining our session. We are API Management, Azure API Management. I'm Elizabeth Barnitt, and I'm joined by Mike and Miao, and we'll be giving you some updates about API Management. So just to kind of give you a rundown what we'll be going through, I'll give you an overview of the service itself, and then we'll give you updates that we've been recently rolling out. So I'm going to start with a brief overview of our service, just for those of you who might not be as familiar with it. So APIs, they enable digital experiences, they simplify application integration, and they underpin new digital products, and they make data and services reusable and universally accessible. And proliferation and increasing dependency on APIs leads to the need for managing them as first-class assets. And so where API management comes in is to help customers securely expose services hosted both on and outside of Azure as APIs. They can control, accelerate, observe them, and ultimately enable their discovery and consumption by internal and external users. So API management is comprised of 3 key components that you can see illustrated on this slide. There's the management API, the developer portal, and the API gateway. So all components of API management are Azure hosted and fully managed by default, but the option to self-host the API gateway and developer portal is also available. The self-hosted gateway enables customers to efficiently and securely manage APIs hosted on premises and across clouds from a single API management service in Azure. And then self-hosting the developer portal allows customers to deeply modify the portal's functionality or extend it with new features. And API providers interact with the service through the management plane, either in the Azure portal or with PowerShell, Azure CLI, the Visual Studio Code extension, or client SDKs in several programming languages. App developers use the developer portal to discover APIs, onboard to using them, and learn how to consume them in their applications. APIs can also be exported to the Power Platform for discovery and use by citizen developers. Requests from client applications first reach the API gateway, which forwards them to a respective backend service. And this API gateway acts as a facade, allowing API providers to abstract API implementations and evolve backend architecture without impacting API consumers. And the API gateway serves as a front door for all API traffic and enables consistent application of cross-cutting concerns like routing, security, throttling, caching, and observability. And API management is integrated with a variety of Azure services, some of which you can see on the screen to the right. There's Key Vault for storing certificates and secrets, Azure Monitor for logging and alerting, Application Insights for live metrics, end-to-end tracing and troubleshooting, Application Gateway, and virtual networks for WAF and network level protection, Azure AD for authentication and authorization, Event Hub for event streaming, and various Azure Compute offerings commonly used for building and hosting APIs on Azure, including functions, logic apps, web apps, AKS, and Dapper. And then API management offers capabilities at every stage of the API lifecycle, and that contribute to developer and operator productivity. I'll call out a few features for each stage, but the features I'll mention are just the tip of the iceberg of API management's offerings. So in the design phase, operators can easily design and mock their APIs. They can import from an open API definition and even import from Azure resources such as functions, logic apps, and web apps. In the develop phase, operators can apply over 50 policies to their APIs and leverage our Visual Studio Code extension for more features such as policy debugging. In the secure phase, operators can ensure their APIs are secure through features such as integration with Azure Key Vault for name values and certificates, request and response validation policies that protect against OWASP vulnerabilities, and private networking using the virtual network. In the publish phase, operators can simplify API discoverability and consumption with the built-in customizable developer portal, and even expose their APIs to citizen developers through custom connectors in the Power Platform to enable low-code app development. In the scale phase, operators can adjust their regional capacity to accommodate API traffic. They could add availability zones to increase individual regions' redundancy, or deploy to multiple regions to reduce the perceived latency of their API calls. In the monitor phase, operators can easily enable diagnostic logs for Azure Application Insights and Azure Monitor to leverage telemetry and for traffic and usage of their APIs, and stream metrics to Event Hub to leverage external log analytics solutions. Finally, in the analyze phase, operators can leverage built-in reports, custom reports with log analytics, and reports in Power BI to help them visualize how their APIs are being consumed and how they can further improve their design. So now I'll hand it over to Miao to talk about WebSockets.
Thank you, Elizabeth. So I'm going to talk a little bit about the newly announced WebSocket API support and our integration with Azure Arc. First, WebSocket API support. We announced it last week at Build. The feature is in public preview and allows customers to manage, protect, secure, and expose their WebSocket APIs in API management alongside their REST and SOAP APIs, so they can manage all their APIs in a single place. The approach we took for WebSocket API support is WebSocket pass-through. Essentially, client applications will establish WebSocket connections with API Management Gateway, and then API Management Gateway will establish WebSocket connections with the corresponding backend services. So there's this one-to-one mapping between client-side and backend side connections. And once this pair of connections are established, API Management Gateway will be able to proxy or broker messages back and forth between the client's applications and backend services. So in public preview, features we support include create, remove, and updating WebSocket APIs using the Azure portal or the REST API. You can also apply policies to the initial WebSocket handshake request before the connections are established, right? You can apply policies like authentication, like validate JOT to these handshake requests. Customers will also be able to browse WebSocket APIs on the developer portal, and you can also test these APIs in the Azure portal and the developer portal using our test consoles. And finally, we will provide metrics and logs through our Azure Monitor integration. So here's a quick demo of the feature. Next slide, please. And let's play the video. So I'm here in the Azure portal. This is my test API management instance. So to add a WebSocket API, I will first go to the APIs menu. And as you can see, there's a new tile here called WebSocket. If I click on that, I can provide information about my WebSocket backend to add my API here. This is very similar to REST API. So as you can see, I need to provide a WebSocket URL. So in this case, I'm just using a very simple echo API, which sends back whatever it receives. So now the API has been added. As you can see here, there's a system operation called onHandshake, which is created out of the box. This allows you to catch the initial WebSocket handshake and apply policies to it. And if we go to the test console here, this is where we can play with this API. And first, let's click connect, and it will try to establish a WebSocket connection. As you can see, it has connected now. Now, let's try to send a test message. Let's say hello world. And now in the output, we can see messages going out and coming back, right? As I mentioned, this is a very simple echo WebSocket API. This is how you can test WebSocket APIs using the test console here in the Azure portal. Now on the developer portal, as I mentioned, customers can discover WebSocket APIs here as well. You can see both REST and WebSocket APIs. And if I click on WebSocket API, I can see some metadata about it, such as the socket URL and the WebSocket protocol supported. Similarly, if I click on Try It button, this is the test console, and I can try to connect from here to this WebSocket service. And then now it says it's connected, and then I can start sending messages to it. And this is very similar to the test console on the Azure portal. Basically, it shows messages coming back and forth basically the interactions with this API. So that's a quick demo of this feature. As you can see, it's fairly straightforward to publish WebSocket APIs. The process is very similar to how you publish REST APIs in API management. And the feature is currently in public preview. The release is still ongoing, so it will take probably a few more weeks for all the service instances to get the feature. So stay tuned. Next slide, please. Next one. All right, so self-hosted gateway on Azure Arc. If you're unfamiliar with our self-hosted gateway, basically it containerizes our gateway components in API management and enables customers to deploy the gateway anywhere as a container image. The self-hosted gateway expands our support for hybrid and multi-cloud environments and enables customers to securely and efficiently manage their APIs running anywhere. And that feature has been generally available since April 2020. So last week at Build, we announced self-hosted gateway on Azure Arc for Kubernetes. So what's new here is that with our integration with Azure Arc for Kubernetes, it enables customers to install our gateway in any Arc-enabled Kubernetes clusters as a cluster extension through a unified and consistent experience across all Arc-enabled services. For example, you can now deploy API Management Gateway, App Service Bundle, and Event Grid on your Arc-enabled clusters through Azure Portal, ARM API, or the Azure CLI. So with that, let's take a look at a quick demo of our integration with Azure Arc. Let's play this video. So I'm here in the Azure portal again. This is my APM instance. So if I scroll down to the gateways menu item here, you will see that currently this APIM instance has no self-hosted gateway deployed anywhere. It's empty, right? So now let's switch to the next tab here. So I have an AKS cluster, which is connected to Azure Arc. As you can see, this is the resource that represents that connected cluster. And if we look at the status here, you can see that this cluster is currently connected, right? So everything looks good. If I go to the extension menu item here, you can see currently there's no extension installed on this cluster. So if I click add here, I can see API Management Gateway on this in this list. And if I click create, and this is where I can create a cluster extension for my API Management Gateway. So let's first select the APIM instance that we want to use to federate this self-hosted gateway. And we can create this logical resource of the gateway from here in place. And let's say the location is AKS cluster. And additionally, I can specify the namespace where I want to install this gateway in the cluster. And I can also provide other configurations like service type, HTTP and HTTPS ports, things like that. And in the next tab here, we can specify whether we want to enable Azure Monitor in this gateway. And we can also provide additional metadata such as tags for this extension instance. And now let's go and start installing the extension. So what's happening behind the scene is that we are installing this cluster extension, which actually deploys the Helm chart of our self-hosted gateway. So now the deployment has completed. So supposedly I have a gateway running on this cluster now. So if I go to go back to the connected cluster, if we refresh the extensions list, now we can see that the API Management Gateway extension is being installed, right? The install status is pending. So if we keep refreshing, after a couple of minutes, it will change to installed, right? So now this extension has been installed and running on this cluster. If we go back to our APM instance and in the gateway list, we can see that there's a gateway which has been, which is federated by this APM instance, and it's sending heartbeats back and forth with the control plane, and the things seem to be up and running, right? So that's a quick demo of our integration with Azure Arc. So as you can see that Azure Arc provides this consistent and unified experience for you to manage all your extensions across all Azure services, right? And you can use the same experience to manage all your components deployed on any Arc-enabled Kubernetes clusters. So that's the quick demo on Azure Arc. With that, I think I'm going to hand it over to Mike.
Thank you, Miao. In the last few months, we added validation policies to Azure API Management and validation policies are 4 policies that help you validate requests and responses against the API schema to protect your APIs from common threats and vulnerabilities like excessive data exposure, mass assignment, injection, and denial of service large payload attacks. The first 3 vulnerabilities are the most common vulnerabilities that are mentioned by the OWASP organization in the API top 10 vulnerabilities list. The denial of service large payload attack is an additional measure that is an additional attack vector that can bring your APIs down. In the demo, in the next slide, I will show you those policies and the capabilities and how they protect your APIs. I will start by explaining the API documentation in a developer portal, just like a typical hacker would do. So in this demonstration, I will be assuming the role of a hacker. And there is one API that exposes the inventory of a company with 3 operations: the get product details, update product description, and get a list of products. And products have a few fields that denote like description ID, etc. So the first attack vector I want to discover is the excessive data exposure. So I'll be comparing the properties returned by the API versus what's documented in the developer portal. So when I make a get list of products call, I get 3 products. With the properties, nothing looks suspicious here. Like one of the products, for example, is an abstract sculpture for $800,000. The headers look all right as well. There is a bunch of them that's not useful. It's not documented, but they don't contain any sensitive information. So this time I will check the get product operation, which should return a bunch of properties of a product and 1 header, which is content type. The properties look the same as in the API documentation, but when I navigate to headers, I can see the same headers as in the previous operation, plus 3 more headers with warehouse ID, warehouse GPS coordinates, and warehouse passcode. Of course, those headers shouldn't be exposed in the API, and it's clearly a bug that leaks the sensitive and confidential data to the client applications or consumers of the API. This can happen with headers, or it can happen with any other properties like object properties or potentially status codes. In API Management, you can protect against this vulnerability by applying a validation policy on the outgoing response. So on the response that's returned from the backend service through API Management to the client application. In this example, I'm applying a validate headers response, which will block headers that aren't documented in the API definition, as well as it will block headers that don't match their definition in the API schema. The following headers that I selected are the exception, which we saw they can be in the response, but they aren't confidential, so we'll ignore validation for those headers. And now when I make a test API call, the headers are no longer there, and the message, the status code is 400 bad request. So API Management blocked the response from the backend service before it reached the client application, just because it contained those undocumented headers. And this policy will prevent any undocumented header. So not just remove this particular one or block this particular one, but any header that's not contained in the documentation. Now, in the next example, I will be trying to exploit the API from 3 more angles. So injection attack, I'll be trying to inject a SQL command which should be blocked because the description field accepts only a regex that doesn't allow semicolons. So we'll try for that. And let's see if this call works. And the backend, the API returns 200 OK, which means that this request went through to the API and was executed in the backend. The good thing is that it didn't break the backend service, but the bad thing is that the backend service accepted that request. There might be a regression in future in the backend service where the backend will execute the SQL command. So this request should be blocked on the API level and not allowed to the backend, especially because it doesn't match the regex. In the next example, I will try to change another field that's not the description field. So I'll try to modify the price field, which shouldn't be allowed according to the documentation. And that's the so-called mass assignment vulnerability. And it succeeded. I was able to change the price of the item from $800,000 to $1. Who doesn't like the discount, right? And just to confirm that I was able to do that, I can now make a GET call, and it also returns $1 price. So it, in fact, propagated to the data contract. This happens very often when developers bind the data contracts to API contracts or the other way around. So they override the properties that shouldn't be overwritten. And lastly, I will try to break my API by providing an excessively large payload. In this example, it will be 10 megabytes payload, which I will mention, repeat the sentence, I will always protect my APIs. And of course, if there is no limit for 10 megabytes, there's probably no limit for 1 gigabyte, 1 terabyte, or 1 petabyte. And those large requests will become a bottleneck in the processing of any other API calls. They may bring the APIs down. In this example, I got the 200 OK status code, which means that I was once again able to find an attack vector on my API. All these vulnerabilities can be alleviated with one policy, which is the validate content policy, which validates the body of the request that is forwarded, that is sent to the API management service. I will set the maximum size of the allowed request to 10 kilobytes, which is 10,000 bytes. And I will also validate the schema of the request of the application JSON content type to the schema in the API definition. So the schema in the API definition allows me only to change the description field, not any other field. And it will also validate the regex pattern so that semicolons are not allowed, therefore preventing the injection of SQL commands. Now let's see if that policy worked. So I'll make a test call again. And this time it resulted in 400 byte request. The excessively large payload was blocked by the API management service and not forwarded to the backend service. When I try to change the price property, API management doesn't allow me to do that because it's not documented in the portal. It's not part of the schema. And lastly, let's try to pass the SQL injection command to see if the regex is enforced. And once again, I get a 400 byte request, a response saying that the description property doesn't adhere to the specified regex pattern. So with two simple policies, I was able to protect my APIs against 4 common attacks. And of course, API management allows 2 more validation policies. One is validation of status codes, and the other one is validation of request parameters, that is headers, query parameters, and path parameters. The next topic that I want to share with you today is the API portal. API portal is built on top of our developer portal in API management. So we took the developer portal, we forked it, and we modified the code base to disconnect the developer portal from the API management service, but it still shares the majority of the code base. So it has the same visual editor for styling and customizations and content editing. And it also has the same API reference pages, etc. Some of the functionality is removed, like for example, user management, because that's part of the API management service. So this API portal can be used to create an enterprise-wide API catalog for discoverability and the duplication of assets and business efficiency, or it can also be used to create a branded API documentation portal for partners or external consumers for the same purpose, as well as to allow self-onboarding. The portal is, we recommend a GitHub-based approach for hosting and managing the API portal, which allows you to not only use the source control, but also automate portal deployments with GitHub Actions, host the site for free with GitHub Pages, and also communicate with application developers through GitHub issues and GitHub discussions. You can visit the repository under this link at the bottom. Now we can move down to the next slide. So in this demonstration, I will show you how I can spin up my API portal. This is the repository where all the information is contained, all the source code, the documentation, etc. It's a public open source project available on GitHub. And I will start by forking this repository, so create my own instance of this repository in my own personal directory, not in the organization's directory. The first step that I want to make is I want to publish my first API to this API portal. So I need to do a few things before I do that. First, I need to change the repository name so that my portal is published under the root directory. So not after a suffix with GitHub pages, but under a root directory. Next, I need to enable GitHub pages. I will point the GitHub pages branch for the GitHub pages content and save. And lastly, I will enable a GitHub action that will automatically publish the portal every time I make a commit to the main branch. This GitHub action is provided for you. It's pre-built into this repository, so we just need to enable it. And now I can navigate to the API specs directory folder. And there is already a bunch of API specs, but I want to publish my API. So I can just drag and drop an open API spec into this folder on GitHub in the browser without doing anything else like outside the browser, and commit it to the main branch. So using the visual interface of GitHub, I can just commit the spec. And I added a file, I added an open API file, which triggered a GitHub action. So once the GitHub action is completed, I will be able to see this API document in the API portal. But before it is completed, let's visit the default API portal. You might be familiar with some styling here. These are the free APIs that come built in as an example in the repository. The API reference pages contain all the information about the representation of requests and responses. You can switch between JSON views and table views. So basically any API documentation information that you might want to publish. Of course, you can also switch between API operations, and the descriptions are different for every API operation, etc. So it's all nice and dynamic. And lastly, you can also use the same interactive console. So you can make an API call to an API that's published in the API portal, and still it works. And you can also use the code samples to get easily started with writing applications in the language of your choice. So let's now try to see if the GitHub action has completed. And in fact, it has just completed. So now if I go back to the API portal, that's, by the way, once again, hosted for free with GitHub pages, I can just refresh it, and I will be able to see the API, demo conference API in the list. It also contains a bunch of operations that are automatically created based on the open API file. The next step will be to customize this site. And for those of you who have played with this self-hosted portal in Azure API Management, you need to fork the GitHub repository on the local machine and then open a web server that will present you an administrative interface for customizations and content editing. So it's very similar to how the self-hosted portal works in API management, with an exception that the content isn't saved to an API management service, but it is instead saved to a local folder on your local machine, which is source controlled by Git. So any changes to the content customizations will be in the source control, and you will be able to commit them to the Git repository, which in turn will trigger once again this GitHub action, which will update the API portal. So I can open the administrative mode once everything starts. I can open it under localhost 3000. May take a few minutes to get things ready. Okay, it should be working now. And once I access this administrative mode, I'm presented with the same visual editor that's used in the developer portal of Azure API Management. I can upload an image, just a sample image, to demonstrate how you can change things, how you can customize things. Of course, there's many more capabilities that I will show in this demo. but just the basics ones. I can change the image in the background to the just uploaded image. And I can also navigate to the styling guide to change typography and all the other visual elements. But in this example, I will change the colors from blue to dark red so that they go well with the newly uploaded image. That will change all the references of the blue color. So for example, all the links will now be red instead of blue, and we'll see that in a second. After the changes are saved, I can go back to the home page. As you can see, the links are now red, dark red, not blue. And I can also edit the headline. Welcome to the API portal. Save the changes, and that's it for the purpose of the demo. So I will save those changes. I will run a git command to show you that those changes are in fact source controlled by Git. They are listed as changes. Now I can add them, stage them, write a commit message, and push them to the GitHub repository. The GitHub action has triggered, and once it completes, which should happen anytime, now I'll be able to see the modified, customized developer API portal. So the GitHub action has completed. And now if I go back to the API portal, I can see that the changes have taken effect. So the image is different, the colors are different, and the portal is now customized. It contains all the 4 APIs that we just saw because I didn't touch any API specs. So in just a matter of a few minutes, I was able to publish an API documentation site for my APIs, customize it, and also, what's more important, create a GitHub-based API ecosystem, not only for source control and automated deployments, but also hosting the pages for free and communication with application developers through issues and discussions where they can point to particular open API specs, or maybe even contribute to the open API specs in the repository. So that's it from my side. Thank you for watching.
Thanks, Mike and Miao, for those demos. I'll just wrap things up with one more update. So Azure API Management, we recently added support for availability zones to enable geo-redundancy of your service. And with this feature, you can deploy your service, including all API management components, with a maximum of 3 zones in a single region, which will allow you to obtain a 99.99% SLA in that region. And with this, any service units must be evenly distributed across zones. So if you want to add 2 zones, for example, you should have 2, 4, 6, etc. units in that region. And this feature is available in the premium tier in all Azure regions where availability zones are enabled. And as always, these are our resources. Feel free to learn more about API management, and then we'll open it up for questions.
Yeah, thank you, everybody. We have a couple of sessions indeed still left unanswered. Let me see. I'm not sure if you can see these questions yourself as well. They are in the accepted pane. What is it? I believe we have around 5 more minutes while in the stream, so we can still take a couple of questions. To start with, there's a question from Philip. He asks, do you know if Microsoft will be creating an enterprise integration learning path and certification? Excuse me, this has already been answered. Well, we are not aware of it. John Fancy and Derek Lee might know. Question from Thijs has been answered. Let's scroll down a little bit. Here, a question from David. Is the VNet support still only available in the premium tier for production workloads?
That's correct, it still is.
Okay, so there you have your answer, David. Question from Konstantinos, it has been answered. More questions. Here there's a question from Ivo. Is it possible to automatically generate the validation policies based on the Open API spec?
You're muted, Mike.
Sorry, still not enough time in the pandemic. I was just about to answer this question that it's not possible to automatically generate those policies based on the Open API spec, but they use the information from the Open API spec. So the information is dynamic, comes from the Open API spec, but you need to configure the policies manually.
Okay, right. Next, we have a question from Ricardo. Is or can the API portal be integrated with the API management?
It can be integrated. The widgets will be similar, but if you already plan to integrate with API management, it's probably better to use the developer portal that's built into API management. But you can compare the two repositories and also move pieces around. So it's possible to integrate it.
Yeah, okay, sure. Makes sense, makes sense. Next question from Ahmed. What does the API portal provide beyond the built-in developer portal?
So the API portal, developer portal is more advanced because it has the functionality of users and API reports, etc. So all this information comes from the API management service, and therefore the API portal, which doesn't require an API management service, doesn't have that. So you can think of API portal more of a static site with API documentation that you can publish anywhere, including GitHub pages or any other solution that's disconnected from any service. You may also use it to publish the API documentation from different API management solutions, not only Azure API Management. So any API that you might have, you may use the API portal to publish that documentation. Alternatively, you can also use it to redirect list all the APIs, so have it as a first discovery point for APIs, and then just redirect the users to a particular developer portal to onboard to the APIs.
Okay, fantastic. Yeah, thank you, Mike. I think we have reached the last one, so that works out fine. There's a question from Owais. Could you see Azure front door capability shifting to APIM in the future?
I'm not sure what you mean by shifting to APIM, but front door is a different product that has a very different architecture and functionality and different purpose. So I don't know if any functionalities will be shifted or not. What we want to work on is better integration with Azure Front Door, so that it's easier for you to provision Azure Front Door in front of Azure API Management for better performance and geo-replicated caching.
Yeah, sure, makes sense, makes sense. Yeah. A couple more questions popped up that are not yet moderated. I think we have to leave the stream, so I'll approve them, so you can check them out under accepted, and then maybe you can take them offline. There are 6, 7 questions, something around that. Yeah, on behalf of the audience, I want to thank you, APIM team, for this session. And also, yeah, the audience, thank you for joining this session. A lot of good questions, a lot of good interaction, good audience statistics as well, around 270 attendees as an average. So that will bring us to the next session that we will have in 10 minutes. Oh, wait a minute, it's 10 minutes. Oh, in that case, we can still take a couple of these questions. I thought it was already in 5 minutes, but it's only in 10 minutes. Let's approve the other questions, and then we can have a look at them as well. So what do we have? Yeah, how can we deploy API management to different resource groups? Is there a simple way to do so? We have been struggling to make a template to deploy. Is there any plan to make such deployments easier? There's a question from Himanshu.
I'm not sure I understand the question. Looks like you're using ARM templates to deploy APIM instance, because you mentioned templates. So when you deploy ARM templates, you should be able to specify the resource group where you want to deploy your APIM instance. So I would need to understand better about the challenges you're you're facing with, feel free to email me at miao.jiang@microsoft.com.
Okay, fantastic. Yeah, fantastic. Yeah. Okay, and we have a question from Wilco. If you have an APIM instance in each OTAP, yeah, so DTAP actually environment, to what instance do you connect the developer portal? To what instance of the developer portal do you allow externals to connect? So DTAP clearly is what the development, the test, the acceptance, and production environment.
So I presume it's for the developer portal and for the API portal. And I'm not sure if I understand what OTAP is. So if you mean environment like production, staging, etc., you always want to use the production environment for the developer portal, especially if it's external facing. If you mean replication like in different regions, API management has a functionality to replicate the gateways in other Azure managed regions. So you can have one developer portal and you can have gateways across the world. And you also can have self-hosted gateways. So I advise to always use the production version of the developer portal. And yeah, and have it for external, internal audiences, partners, or any combination of them.
Yeah, makes sense. Yeah, thank you very much. Next, what do we have? Yeah, a question here. Is there a better editor or creator for APIs coming out? Something like Stoplight is mentioned?
At this moment, we are not working on a dedicated API editor that's part of Azure API Management. We do have visual editor in the Azure portal. We also ask customers to use, for example, Visual Studio Code. There's quite a few very interesting plugins around building APIs that can also suggest where you made mistakes in the Open API files. And of course, you can also use external tools like Stoplight for creating APIs and then just pushing them to Azure API Management.
Okay, then we have, let's see here, John, here's a question. Does the API gateway support two-phase commit with distributed transactions, either as a pass-through or with a transactional endpoint?
Sorry, where is this question?
Yeah, sorry, that was still pending unapproved.
Okay. Sorry.
Just approved.
Two-phase commit distributed transaction. I think it would be easier to have it on an example.
Yeah.
But I don't think it does. API Engine just lets API requests, passes them through to the backend services, and it allows you to mediate them with policies like, for example, transformation. But it doesn't group API requests except for the WebSocket functionality that Miao just demoed.
Thanks, folks.
Thank you all for joining.
You're welcome. Okay.
Cheers.
Covey.co